Okay, so we're going to go over piecewise functions again. And remember what I said last week about piecewise functions. It is best if you just look at each piece of the function first and decide what that's talking about. So let's come over here. All right, so I know that there are three pieces, and for some of you, using different colors of pencil or pen might be helpful. So notice this first function. This first function just says f of x is equal to 0. And remember the constant function, that f of x equal to a value is just a horizontal line at that value. So we know we have a horizontal line at 0, but the only piece that we care about is where x is -1. So if we put where x is -1 or smaller. So the graph would look something like this. All right. Notice I still have part of the graph covered up. So then I'm going to go ahead and take a look at this second piece, and notice it's an absolute value function. Remember, absolute values graphs look like V's, and it has been shifted. Remember, if it's inside the absolute value, it means it gets shifted left to right, and you always do the opposite. So the opposite of -1 is +1. So if we are on the number line, instead of the V looking like this, it would be shifted over like that. All right, so and the only parts that we have to care about, what that graph looks like between -1 and +4. So there we have it. So if we were to do this, whoops, remember we moved over 1. It should have started here, but we moved over 1. And we draw the graph until the x value says -1 and +4. On the +4, as we go up, we put a solid dot because there's a solid line right there. And where x is -1, we go up and we put a hollow dot. So there's the second graph. And the third graph is a square root function. Let me change that to blue now. And it has been shifted, the opposite of -2, it has been shifted right too. So instead of starting here at 0, this whole thing would get moved over starting at 2, and it'd look something like this. So notice, here, let me put this. It would have started here, and the graph would have looked like this. However, this tells us the only part that we care about, so you look up where x is 4, and you go up, put a hollow dot, and go ahead and do the graph, and then this other piece, you just erase. There you go. That is a piecewise function. So let's go ahead and go on to, now we've been working on a transformation of functions. So this says x squared. So that's just your basic x squared graph. Then remember, you have to look at how is it going to be transformed. Well, if it's inside parentheses, that means a shift left or right, and it's the opposite. So it gets shifted left -1. So in words, a way to write that would be shifted left 1. And then there's this fraction on the outside. And remember, when it's an integer on the outside, it gets steeper faster. If it's a fraction, and think about that, it's 1/3 as tall. And sometimes we call getting taller a stretch. And when it's shorter, sometimes they say it was shrunk. So, and that's what I'm going to go ahead. Shrunk by a factor of 3, or think about it as 1/3 as tall, and it's going to look like that. The black is the original, we shifted to the left one. Went from here is now here, and then it's 1/3 as tall. So if we put 0 in here, 0 plus 1 is 1, 1 squared is 1, 1/3 of 1 is down here at 1/3. If we put a 2 in there, or I'm sorry, a 1 in there, 1 plus 1 is 2, 2 squared is 4, 1/3 of 4, we're up here at just a little taller than at 4/3 or 1 1/3. Put a 2 in there, 2 plus 1 is 3, 3 squared is 9, 1/3 of 3, 1/3 of 9 is 3. There we go. All right, let's keep going. Again, another transformation. This is now a cubic. So here's our basic cube graph. Notice we've got another inside shift, so that means that we shift left or right, and this is going to be a stretch. It's going to be 2 times as tall. So it got shifted. The opposite of -2 is 2, so we shift it right 2, and then when it's going to be taller, that's called being stretched by a factor of 2. And then let's look to see what that graph looks like. So notice, if the original one looks like this, it got moved over 2 right there, and then look it is steeper faster. There you go. All right, and then we have this rational or inverse function, and the normal graph of 1 over x looks like that. Notice there are 2 asymptotes. The red line, the red dashed line represents the asymptotes, and then the black line represents what the graph looks like. So 1 over 1, we're right here. 1 over -1, we would be down here, and then the rest of that graph looks like this, so forth. All right, but what is happening here? Well, there's a negative sign on the outside. Remember, when a negative sign is outside the function, it means it's reflected over the x-axis. And think about this +2 being inside parentheses. If we wanted it to go up and down, we would have put a +2 on the outside of that fraction. But because it's not, we know that, again, it has been shifted, and the opposite of +2 is left 2. So if normally there are asymptotes vertically and horizontally, right there on the axes, when it's shifted left 2, at -2 there's going to be an asymptote. So the graph would have looked like this, but instead there's a reflection over the x-axis. So this right here is now shifted down here, and this piece right here is now reflected over the x-axis. So let me go ahead and, so this stuff just gets erased. And I don't know what I'm wasting my time doing that. There you go. So notice, this right here, or this asymptote right here, got shifted over 2. And then this graph right here got reflected. So it was shifted over 2, and then it got reflected. And then this graph that was here got also reflected over the x-axis. All right, that is just a kind of a quick reminder of how you do the parent graph transfers. That's it.